Welcome to this explainer. Have you ever stopped to wonder how a simple oak tree becomes the ultimate active ingredient in your absolute favorite wines? I mean, we so often think about wine purely in terms of the grapes or the terroir, right? But the vessel it ages in, that's a living, breathing participant in the whole process. Wood is definitely not just some inactive container to hold liquid, it is a profound flavor creator. So today, we're going to trace this epic, fascinating journey of how raw oak is transformed through nature, science, and some really rigorous craftsmanship into the ultimate tool for winemakers across the globe.
All right, here's our roadmap for today. We'll kick things off with the anatomy of oak, then head out for selection in the forest. From there, we'll cover survival at the sawmill, crafting in the cooperage, and finally, shaping the final barrel. Let's dive right into Section 1, the anatomy of oak. To really understand the barrel, we first have to recognize that wood is a highly complex chemical canvas.
If we break down that chemistry, it's actually pretty amazing. Exactly half of the wood is just cellulose. Now, cellulose is fascinating, but it's got a flaw. It can rot when it's exposed to humidity, and it gets this dark, murky color. Which brings us to the next 30%, and that's rigid lignin. Lignin is absolutely vital because it's the armor. It provides the structural protection the wood needs. And then you have the remaining 20%. These are various materials, mainly hemicelluloses, natural colorants, and resins. Honestly, these are kind of the unsung heroes because they're what make the wood beautiful, resistant, and workable for the barrel makers.
Moving right along to Section 2, selection in the forest. Long before any cutting happens, geography, mineral-rich soil, and sunlight are already dictating the raw potential of the oak. So get this, for an oak tree to even be considered for barrel making, it needs to hit a very specific sweet spot, between 80 and 120 years old. Why such a narrow window? Well, if a tree is too young, it just doesn't have the dense wood or the complex phenolic compounds that create those amazing flavors we want. But if you let it grow too old, the wood becomes overly dense, making it incredibly difficult to bend and work with. So 80 to 120 years is kind of the Goldilocks zone.
And then we have a literal species showdown. On one side, you have Quercus petrea, known as French oak. This is heavily prized for its refined, elegant structure. We're talking delicate floral notes of violet and jasmine, mixed with hints of white pepper and apple. It's subtle. On the other side, Quercus alba, or American oak. This one acts like an absolute powerhouse. It delivers strong, robust tannins and these intense, almost dessert-like aromatics of toffee and coconut. So the choice a winemaker makes between these two fundamentally alters the entire personality of the wine. But it's not just about the species. We also have to talk about the wood grain. The grain is essentially those growth rings that develop radially inside the tree's trunk. When we're talking about premium wine barrels, narrower rings, which means a much finer grain, are highly, highly preferred. The physical density and the tightness of that fine wood grain directly dictate a much more gradual, beautifully controlled extraction of all those incredible aromas and flavors. It essentially stops the wood from overwhelming the wine all at once.
All right, that brings us to Section 3, survival at the sawmill. Because once that perfectly aged tree is harvested, it has to survive some seriously rigorous tests of durability. This is where the wood goes through an incredibly chaotic transition. It has to drop from a freshly felled 60% relative humidity all the way down to an air-dried 15%. Now, because wood naturally absorbs and releases moisture from its environment, this drying process causes massive volumetric instability. It shrinks, it swells, and if it stays too damp, it's going to warp uncontrollably, which means it will be completely useless for creating a liquid-tight seal later on.
And honestly, moisture is just the tip of the iceberg. There are so many physical obstacles that can instantly ruin a stave. You've got spiral grains, where the wood fibers literally grow in a helical shape. There are knots, which happen when a growing branch gets swallowed up by the trunk, and that creates a dangerous structural weak point. Then you have the devastating cracks. You've got checks, which are deep cracks cutting straight across the growth rings, and ring shakes, which run parallel to them. And if that wasn't enough, you can get torn grain when fibers physically rip up during planing. Plus, beyond the structural flaws, the wood also faces biological threats, which are called alterations. These are actual diseases that hijack the chemical composition of the wood. So only the most pristine, perfect cuts of wood are going to survive the threats of fungal molding or total rot and destruction from insects and mollusks. It is literally survival of the fittest out there. Okay, on to section 4, crafting in the cooperage. The surviving heartwood finally reaches the artistry of the barrel makers, where heat is used to unlock its absolute magic. This is where things get really cool. Because the staves are subjected to progressively higher and longer heat, it creates a literal ladder of intensifying flavors for the wine. Step 1 is a light toast. Gentle heat that yields subtle vanilla and coconut. Step 2 is medium toast, applying moderate heat for a bit longer to release intense caramel and spice. Then you step up to medium plus for some really deep complexity. Step 4, heavy toast, actually carbonizes the surface of the wood, imparting intense smoke and coffee notes. And finally, extra toast delivers massive, pronounced smoky notes that are honestly meant only for the absolute most powerful wines. And that leads us nicely to section 5, shaping the final barrel. Once the wood is toasted, it's time to bend it into shape. The degree of curvature applied completely determines the shape, the capacity, and the specific function of the vessel, and it's totally tailored to the wine. A classic Bordeaux barrel is cylindrical with a wider center, which is just perfect for red wines. But a Burgundy barrel is a bit wider and lower, better suited for elegant reds. Then you can step up to the big leagues, like a 300-liter hogshead used in Australia, or a 500-liter puncheon favored in the Rhone Valley. There are even massive 600-liter casks common in Spain and Portugal. The surface area to volume ratio of these different shapes completely changes how the wine interacts with the wood. But wait, there's one last wild card here. Winemakers have to consider a barrel's past. You have to remember that a barrel acts as a living memory bank. A stave's history with past vintages directly influences the flavor of future batches. The wood absorbs elements from whatever it held previously, adding yet another layer of complexity. Which is exactly why the decision to use a brand new barrel versus a previously used one is a huge strategic choice in winemaking. So as we wrap up this explainer, I want to leave you with a final thought about this incredible, active journey of the oak tree hidden right inside your glass. Next time you pour a glass of your favorite wine, take just a moment to look past the grapes. Think about that 100-year-old forest, the chaotic drying process, the intense heat of the cooperage, the grain, the toast, the shape. What story is the wood telling? Thank you so much for exploring the incredible science and artistry behind the barrel with me today. Keep asking questions and keep exploring.